Our equation here is a mole ratio. This is telling us our four things that will combine and how they'll combine, and it tells us the ratio they'll combine in. So if I look at this, I have some oxygen and it's going to give me some carbon dioxide. And it's going to do that in a ratio of 13 to 18. So if you remember, one thing I'd suggest is bracket these guys. That shows you that's my compound. And the number in front tells you how many. So I have 2 of these, 13 of these, result in 8 of these, and 10 of these. And I can make that a fraction. I can say 13 moles of this. I just put the word mole in front of here. Gives me 8 moles of this. For every 13 moles of oxygen, I have 8 moles of carbon dioxide. Alright, I just take what I have. And I could do that with anything. That's the key to stoichiometry. Stoichiometry is the same thing we did yesterday, but I'm using mole ratios. So let's say this is my problem here. How many moles of oxygen needed to produce 3 moles of carbon dioxide? Alright, just like yesterday, my first step is to take the given. I have 3 moles of CO2. That's the only number and unit I have, so I have to start with that. 3 moles of CO2. My next step, I don't want moles of CO2, so I'm going to put it down here so I can cancel it out. Alright, what can I change it to? Well, I'm looking to get to moles of oxygen. So if I want to change from one chemical to another, that's the time to do it. I can go from moles of one thing to moles of something else. That's what I had, that's what I want. Now remember yesterday I said, look at your fraction. If there's only 1 mole in there, you always put 1 mole. But clearly, there's 2 moles. So if there's 2 moles, we're going to get our numbers from somewhere else. And we're going to get them from our equation. And again, just to bracket this to make it clear. Alright, so I have O2. My number in front of O2 is 13. My number in front of CO2 is 8. Alright, so I have a mole-to-mole ratio. I go to my equation to get my numbers. I'm going to cross off my like units. Now I'm in moles of O2. Am I done? Well, I'm looking for how many moles of O2, so I've matched it, so I'm done. So I'd multiply and divide, and that would give me my answer. Alright, here's our next problem. Now I'm looking for how many liters. Well, I have, let's look at what my given is, 7 liters of CO2. I'm just going to start by writing that. Okay, I don't really have to think about the problem much, I just write my given. And then once I have my given, I put it down here because I know it's always going to cancel. Now what can I change liters to? There's only one thing I can change liters to, and that's moles. And if I have liters of CO2, I have to have moles of CO2. I look at my fraction, there's 1 mole, that means there's 1 mole. And then my liters on the bottom, that's a number I have to memorize. It's always 22.4 liters per mole. Cross off my like units, I have moles of CO2. But my question says liters of O2. So I need to get out of CO2. So I'm going to take my units down here. Whatever I have up here goes down there. Now I don't want CO2, I do want O2. So I'm going to put the chemical I do want on top. And I can always change from one chemical to another with a mole-to-mole ratio. Alright, this fraction had 1 mole, so I use the number 1. This fraction has 2 moles, 1, 2 moles. So I can't use 1. I have to go to my equation. Alright, so O2, again, the number in front of O2 is 13. The number in front of CO2 is 8. Cross off my like units. Am I done? Well, I'm at moles of O2, but I want liters of O2, so I got to keep going. Alright, so I'm going to take whatever units are up here. I don't want them, so I'm going to put them down here and cancel them out. I'm trying to get to liters, and I can go from moles to liters. There's 1 mole in my fraction, so there's 1 here. My liters, again, is constant. It's 22.4 always. I cross off my like units. And then I'm going to multiply everything across. Okay, I'm in liters of O2. The question says liters of O2, and I'm done. So I have 7 times 13, 22.4. I'll use parentheses on my calculator, and I'll get my answer there. Alright, my next question has grams. We're starting off with 100 grams of water. So I'm going to start by writing my given. Okay, I don't want grams of H2O, so I'm going to put it down here to cancel it. There's only one thing I can change grams to, and that's moles. And if I have water down here, I got to have water up here. My fraction only has 1 unit of moles, so I always use 1. My grams comes from the periodic table. I have 2 hydrogens, and I have 1 oxygen. I go to my periodic table, I look up hydrogen, it's 1. I look up oxygen, it's 16. So I have 18 grams. So 1 mole of water has a mass of 18 grams. I'm going to cross off my given. Now I'm in moles of water. Am I done? Well, I'm looking for grams of C4H10. So I'm not done. So I'm going to take my units up here and put them down here. Alright, so I'm in water, but I want to get to C4H10. So this is the time to go from one chemical to another. And to do that, I use my mole to mole ratio. Now I have 2 moles in my fraction, so I'm not going to use my 1. Instead, I'm going to look for my C4H10. It's up here. And I have 2 of those. And I look for my H2O. And I have 10 of those. I'm going to cross off my like units. And then I'm going to figure out if I'm done. I'm in moles of C4H10. I want grams of C4H10, so I got to do another fraction. I'm going to take my units. And I want grams, so I can go from moles to grams. 1 mole in the fraction means 1 here. My mass of this, I have 4 carbons. I have 10 hydrogens. Just take that from the formula. I go to my periodic table. Carbon is 12 grams. Hydrogen is 1 gram. I add those together. That goes there. Cross off my like units. I'm left with C4 grams of C4H10. I'm looking for grams of C4H10, so I know I'm done. And I'm going to multiply 100 times 2 times 58 and divide it by 18 times 10. Those are basically your 3 types of problems. And you'll see them reversed, but the process is exactly the same. Oh, one more type of problem. I always forget the molecules. Alright, but the process is going to be the same. I'm starting off with this. So again, my first step is to write the given. I don't want grams of this stuff. Okay, the only thing I can change grams to is moles. There's 1 mole in the fraction, so I'm going to use 1. My grams, well, let's write out the formula. I look up carbon, it's 12 grams. I look up hydrogen, it's 1 gram. Alright, that's my mass. I'm going to cross off the like units. So I'm in moles of C4H10, but I want to get to CO2. So I got to repeat. I'm going to take this stuff, put it down here, because I want it to cancel. And now I'm looking to change my chemical. I'm trying to get to CO2. I have 2 moles in here, so I cannot use 1. I have to go and get my numbers out of here. There's CO2. There's 8 in front. And C4H10. There's a 2 in front. Crossed off my like units. I don't want moles of CO2. I want molecules of CO2. So I'm going to take my units here. Now I can go from moles to molecules. There's only 1 mole in this equation, in this fraction, so I use 1. And I know for molecules, that's Avogadro's number. That's a number to memorize. There's a lot of things in 1 mole, so that's when I use that. Alright, and again on my calculator, I'm just going to take all my numbers. And use parentheses on my calculator. Put all that in your calculator, and whatever you get, just tack on your 10 to the 23rd. Alright, so now we're done. Here's 5 problems. I've given you the answers. Work out each one, calculate it, make sure you get the right answer. Okay, after you do these, pause the video, work these out. There's a second slide with 5 more problems. So you have 10 problems in all. I've given you the answers, and I will work out the problems on a separate video. So part 2 of the video will have the answers worked out if you need that. Alright, so pause the video, do these 5 questions, continue the video, there's 5 more, and repeat.